Hello world. Today we're going to be going over linked lists and how to traverse them. So a linked list is basically a data structure that lets you store a list of data. So it could be a list of integers, a list of characters, a list of objects, a list of anything really. Um, and at first that might sound sort of like an array, and in some ways it is. You can use it for a lot of the same purposes. But it's a fundamentally different data structure. So the main thing that makes a linked list different is that in an array, in memory, you have all of your nodes right next to each other. So you have, if you have, if at position 0 you have like the number 4, then at position 1 you have the number 5, then like in actual physical memory, you have your 4 and your 5 right next to each other. But with linked lists, they're not necessarily next to each other. And that kind of introduces the issue of how the computer actually knows which element comes after the previous one. Because with an array, it knows it just goes one to the right, it just goes to the next byte or whatever the size of what you're storing is, and it knows the next element's there. But with a linked list, we don't necessarily have that because they're not all stored next to each other. Uh, so, so let's go ahead and take a look at what a linked list node might look like. So in a linked list, we don't store just the data, but we store the data, and we also have to store where the data, the next piece of data is. So every node has a data. Let's, for simplicity, make it an int. So these nodes are going to store integers. That's going to be the data that we care about. And it also stores the value of the next node. Uh, so um, so like the way that we would use this is we would have our next node would point to whatever data comes after this. So if we have a list with, let's say we have 5, 3, 2, our first node would have data would be 5, and next would be a pointer to the node that has a 3 in it, and then from 3, that node, its data would be 3, and its next would point to this node with 2, and then from 2 the data would be 2, and next would typically be null. That would be the way that you would indicate that it's the end of the list. So to iterate through a list, you basically just keep following the next pointer. And you can do that in a loop. You can do that recursively. There are a few ways to do that. And let's go through an example where we do just that. So, so let's go ahead and make a node. We can call it head, because so the I guess some terminology first. The head of a linked list is the first node in the list, and you need to store somewhere, because from the first node in the list you can get to the second by following the next pointer, and then from the second you can get to the third, and from the third you can get to the fourth, all the way till the end. But we need to keep track of the actual head of the list because that's how we um, because there's nothing pointing to that. So uh, let's go ahead and make this a new node, and let's just keep it simple right now, not use a constructor or anything. Uh, so we can say head.data equals, let's start it with 5, and head.next we want to explicitly set to null, just to make it very clear that um, that this is going to be our only element in the list, because remember that next is going to be null um, for our last element. So right now this is going to be our first and last element. So this isn't very interesting though. Let's add another element to the list. So to do that, remember that we want to we want next to point to the new element. So we can actually do is instead of setting next to null, because we want to add a second element to the list now, is you can set head.next to new node. So here we're setting head.next and we're creating the next node it's going to point to. And what that lets us do now is now we can say, just to come up with like a placeholder for it, we can call it current equals head.next. So right now this is pointing to our new node. So now that we have our new node here, we're essentially back at this step up here. We can set current.data equals 4 and current.next equals, let's set it to null for now. So what we have right now is we have a linked list where the first element is 5, and then the next element, which you can get to by following the head.next pointer, is this new node, which is our current node in this case, and we are setting that one to 4, and we're setting this to null to indicate that that's our very last element in the list. So let's traverse through this very simple list. So a typical way to traverse through a list would be to first set a let's call it iter. Yeah, let's call it iter, short for iterator. So you'd want to take this and set make some temporary node that we set to head, and then you want to say while iter is not null. So what we're going to do with this iter variable is we're going to, it's going to be pointing to our current node, and at the end of each iteration, we want to say, at the very end, we want to say iter equals iter.next. So this is going to keep going through the entire list until it gets to the point where iter is null. And remember, at the very end of a list, the next element points to null. So what this lets us do is it lets us essentially iterate through the entire list up until the very end. So let's do something interesting within here. Let's print out the value of the iterator. So, and remember, this is just our node right here. So this has the data element that says what's in it. So let's do it on a new line just to make it a little easier to read. So right now, what you'd expect this to do is print out 5 and then 4, because we have 5 as our first element. And then if you just walk through the code really quick, right here, iter points to head, and head is this node that has 5 as its data. So we'd expect this to print 5, and then iter equals iter.next. This makes iter equal head.next, which in this case is this new node that has a 4 in it. So this should print 5 and then 4, and then when it does iter.next on this node here, iter will equal null when it comes back up, so it should just exit the loop. So we should see a 5 and then a 4 and then an exit printed. So let's go ahead and compile this, and there we go. So we have a 5 and then 4, and then the program exits. So so we can add another element to the list by right here we could just say current.next equals new node, and at this point nothing too terribly interesting happens. We can set it to 3, and I want to set current.next equals null, because remember we always want to make sure that our last element in the list has current.next equal to null, because if it didn't, if it equaled some random object, this would resolve to true. So we'd go back into the loop and we would try to process a non-existent node, and this would give us an exception. So this should now print 5, 4, 3. So let's run that. And here we have 5, 3, because I probably messed up somewhere. So we have head.next equals new node, current equals head.next. Oh, okay, yeah. So current.next equals new node. we actually have to set current to current.next, because right here we're just overriding the previous date of current because it was pointing to the same node as before. So now this should print 543. There we go. So yeah, so this is the general way to process a linked list is you just iterate through it until it's null. You might want to do something more interesting here than just print. So for example, we could keep track of a total, and you can say total plus equals iter.data, and at the end we can print out the total, and this would give us the total of all the elements. There are tons of things you could do with this once you're iterating through the linked list. So our total is 12 because 5 plus 4 plus 3 does equal 12. But yeah, and this is the general idea for how to iterate through a linked list. You can do some pretty fancy things with them, but as far as the basic idea of how to create a linked list, how to iterate through one, that's what we have right here. So yeah,